Hello class, this is part 2 of the video for review for the test or quiz for tomorrow. And in our next question, it simply is asking us to find the window that best shows the shape of the graph where it crosses the x-axis and the y-axis. So I'm going to use my graphing calculator to do that, and then I'll bring up the window that shows you the best view of that. So here I have the graphing calculator, and I just programmed in negative 5x minus 60. So I'm going to now hit the graph button, and as you can see, it must have been a previous plot of something from Zoom Stat. So I'm just going to go back and look at some of the other choices I have. For instance, I'll try Zoom Decimal, and I'll see if I see my x and y axis on that, and I don't. So I'm going to try maybe Zoom Standard, the sixth choice. And on this one I don't see it. Let me make sure my plot's turned on. Okay, notice I made a little mistake, I think, on the y-intercept of being negative 60. Oh, it says negative 60. Let me adjust my window so that it goes down to a value of maybe negative 100. And let me get a look at that graph. And there I can see I got the y-intercept, and I don't have the x-intercept yet, so I need to widen the window a bit more. So I will go back to my window settings, and I'm going to change the x minimum value to negative 20. And when I graph that, I should see both my x and y-intercept, and this would be an appropriate window. So I'll just copy and paste that onto our screen. And that would be the best window for that function. Now I'm just going to program in the other function, and I'll be back after I pause the camera for a moment. Okay, I'm back, and I have the function programmed in. Notice I used the fraction bar to help me out with the coefficients, 1/5 and 1/4, and the last constant number of negative 1/5. And when I go to, I'll start out with just a Zoom Standard to see how that looks. Zoom Standard 6, and as you can see here, Zoom Standard shows me that I do see the important information, but I'm zoomed way too far out. So let me try to zoom in a bit, and I'm going to or I can change my window. So maybe I'll shrink the window, so I'll go from maybe negative 5 to 5, and I'll switch my y values from negative 5 to 5, and let's see how that looks if we see any more information. And looking at this, we're a little bit better, but we might need to zoom in a little bit more, so I'm going to adjust my y window setting value. I'm just going to maybe look at from negative 2 to 2, and when I graph that, I should see a bit more information. And here we can see the y-intercept, the x-intercepts, and enough information about the function to say that that's a pretty good graphing window. So I'll just cut and paste that in. So we can at least see what the window was. And when you do get that window, you should write in the values for the x-min and the x-max. So I think this was negative 20, and this went up to 10, and it was a step of 1. And I think the y min on this window was negative 60 or maybe negative 100, and the y max I think was 10, and the y scale, it looks like it was 1 unit. On this graph, the x max and x min were negative 5 with a step of 1, and the y min was negative 2, and the y max was 2, and the scale was 1 unit. On our next problem, the question asks us to find the function value at 2. Remember, this is the x value. So we're going to look for wherever x is equal to 2. So we go to x equals 2 and we go right down to the function, and that tells us our y value was -2. If they had asked for f at 1, we would say its value was 0. If they had asked for f of 0, we would say its value was equal to 2. On the next function, they ask for domain and range. Remember, domain stands for the x values that the function uses. So here it's clear that the domain would be on the interval from -3 to 2 with an open bracket, and the range would be from 0 all the way up to 5 with an open circle there. So this would be from 0 to 5 with an open parenthesis. On the next one, domain and range, I'm going to just color in blue the domain. As you can see, this function here uses all of the values from -pi to 2pi, and it uses the endpoints, and the range uses just the values from -1 to 1 inclusive. Now we have an increasing, decreasing, constant part. So on this interval here, if you look at the function on this interval, the function is decreasing. On this interval, the function is constant, and on this interval, the function is increasing. So if they want to know the increasing and decreasing intervals, you would say increasing on the interval from, I think this is 4, 5, 6, 7, from 4 to 7. It's decreasing on the interval from -8 to, looks like -1, 2, 3, 4, from -8 to -4, and it's constant on the interval from -4 to 4. Finally, the next two problems we did in class, and they're just doing a curve fit or a linear regression for the data provided. So remember, I expect you to show me a nice graph of the data, what the curve fit would be, and use that curve fit to predict values, and also find the correlation coefficient to find out if it's a good fit. Remember, if the r squared value is closer to 1, the fit is better. If the correlation coefficient r squared is heading to 0 or closer to 0, the fit is not a good, well, it's not a good fit or a good model. Okay, I hope this helps, and good luck on your review tonight.